So in this figure, we are given that AD and BC are equal perpendiculars to the line segment AB. Let's understand this information. AD and BC are equal. That's the first thing. So AD is equal to BC. AD and BC are equal perpendiculars to which line segment? To the line segment AB. This means AD is perpendicular to AB. See here, AD is perpendicular to AB and BC is also perpendicular to AB. Alright, so what do we understand by AD perpendicular to AB? AD, where is AD? See, this is AD. AD and AB, these are the two lines. When we say AD is perpendicular to AB, that means the two lines meet at right angles. See here, AD, this is AD, this is AB. The two lines, they meet at right angles. Where do the two lines meet? At this point A. AD is nothing but DA. AB is nothing but BA. The two line segments meet at this point A. There the angle formed is 90 degrees because they are perpendicular to each other, which means angle BAD is 90 degrees. Angle BAD is 90 degrees. Now again, BC is perpendicular to AB. BC is perpendicular to AB. This is the line segment BC. This is the line segment AB. These two line segments meet at right angles. They are perpendicular to each other, meaning they meet at right angles. Where do they meet? See, a BC or CB is this one. AB is this one. These two line segments, they meet here at B. So the angle formed at B is 90 degrees, which means angle ABC is 90 degrees. So let's repeat this one. AD and BC are equal. Equal meaning AD is equal to BC and they are perpendiculars to AB. So understand that separately. AD is perpendicular to AB and BC is also perpendicular to AB. And these are the results we have. Angle BAD is 90 degrees and angle ABC is 90 degrees. Now what do we have to prove? We need to show that CD bisects AB. CD, see the CD bisects AB. That is, CD cuts AB into two equal pieces. Bisects meaning dividing into two equal portions. We need to prove that CD bisects the line segment AB. So which one is bisected? AB is bisected, meaning AB is cut into two equal pieces. So we need to prove that AO is equal to BO. CD bisects AB. So the line segment CD cuts AB into two equal pieces. So which means we'll have to prove that OA is equal to OB. Alright, we need to prove that OA is equal to OB or AO is equal to BO. Both mean the same. Alright, let's see the proof. So here in this figure, these are the information we have. We can say that angle 1 is equal to angle 2 because vertically opposite angles are equal. Before that, which are the triangles we have to consider? We need to prove that AO is equal to BO, right? So AO is of which triangle? AO is a side of which triangle? AOD. So we need to take up the triangle AOD. And BO is a side of which triangle? BOC. BOC. So we take up these two triangles because we have AO in this first triangle and BO in the second triangle. So when you have to prove that AO is equal to BO, you must take up one triangle that has AO as a side and another triangle which has BO as a side. So the two triangles are AOD and BOC. Now let's list out the pairs of equal angles or sides we have in these two triangles. Angle 1 of the first triangle. Angle 1 of the first triangle is equal to angle 2 of the second triangle because vertically opposite angles are equal. Again, angle 3 of this first triangle is equal to angle 4 of the second triangle because both the angles measure 90 degrees. That's given to us. And we also have AD equals BC. AD equals BC. AD of the first triangle. Where is AD? See here, AD. AD is a side of the triangle AOD. So AD of this first triangle is equal to BC of the second triangle. This is the second triangle. Where is BC? See here, BC. So AD of this triangle is equal to BC of this triangle is also known to us, is given to us. Now what have we listed? We have listed two pairs of equal angles and one pair of equal sides. Now what is a rule, congruence rule that we can use? Now, is this side, are these sides the included sides? Let's check that first. So, we have angle 1 and angle 3. In the first triangle, we have angle 1 and angle 3. Angle 1 and angle 3 include the side OA. Watch carefully. Angle 1 and angle 3 include the side OA. But we have mentioned about AD in that triangle. So, AD is not the side included between these two angles. Look at the other triangle. Which are the angles? Angle 2 and angle 4. Angle 2 and angle 4. Angle 2 and angle 4 contain the side BO or OB. But what is that we have here? BC. BC. So clearly AD and BC are not the sides included by these two angles. Alright. So you cannot use ASA. You cannot use ASA. ASA is two angles in the included side. Two angles in the included side. So this is about two pairs of equal angles and one pair of equal sides. The sides not being the included side. So the rule is AAS. 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 Angle, angle, side. So now these two triangles are congruent to each other by the AAS congruence criterion. Now again, the order in which we name the triangles is very important. Now supposing you call this triangle OAD. You can just call it anyways. Supposing you call this OAD. See here, OAD. Match the vertices. Match the vertices and name the other triangle. So when you say OAD, O is what? Angle 1 in the first triangle. O is angle 1 in the first triangle. So we know that angle 1 is equal to 2. So when you say O here, you must say O here also in the second triangle. When you say O here, it's O in the second triangle also, because angle 1 is equal to angle 2. Meaning O, the point is O there. And here is A. A is what? Angle 3. A is angle 3. And we know that angle 3 is equal to angle 4. So when you say A in the first triangle, you must say B in the second triangle. Because angle 3 is equal to angle 4. See here, angle 3 is equal to angle 4. So A in the first triangle means B in the second triangle. So obviously the third vertex C. When you say OB, the third vertex is C. So OBC. So when you say OAD, triangle OAD, you must say is congruent to triangle OBC. These two triangles are congruent by the AAS congruence criterion. So now that we have proved that these two triangles are congruent to each other, it means they are identical triangles. So we can find out the remaining pairs of equal angles and equal sides using the order in which we have named the triangles. Now we need to show that AO is equal to BO. So look at this. What do you have here? OA equal to OB. Can you see this? OA. Can you see this? OA equals OB. Or OA is nothing but AO. OB is nothing but BO. They mean the same. So OA is equal to OB. What's the reason? Now that the two triangles are congruent, their corresponding sides are equal. So we have AO is equal to BO. You can say OA is equal to OB also. CPCTC. You know this, what it means. The corresponding sides of congruent triangles are congruent.